This video talks about covariation and correlation. So covariation describes the relationship between two variables, and this kind of relationship is often expressed with a scatter plot, where here we have the x-axis and the y-axis. And so we're going to talk about the relationship between height and weight. And so we're going to put height here on the x-axis, and we'll put weight on the y-axis. So here we see that the weight is measured in pounds and the height is measured in inches. And so to look at the relationship between height and weight here, we're going to look at a few individuals. Okay, so we have our first person, and we're going to plot the individuals on the chart here. So we have our first person who's about 36 inches in height, so that's right here, and this person weighs about 70 pounds, so that's here. Okay, so we're going to put that point right here, and let's take another person who is about 46 inches in height, so right here. And that person is, let's say, 110 or so pounds. Okay, so put that person about here. And so we're going to continue plotting a number of people, and then we will see the relationship between height and weight. So this shows the 20 people's heights and weights plotted on the graph. And you can see here that there is a relationship. It looks like there is a relationship between height and weight, because as height increases, weight increases, right? So the numbers tend to go along a line like this. So the lower the height, the lower the weight. The higher the height, the higher the weight. So one way of expressing a linear relationship between two variables is by calculating a correlation coefficient. And a correlation coefficient is a number from +1 to -1 that expresses the strength of the association between two different variables, so in this case height and weight. So correlations can be positive, so as I said, up to positive from 0 to +1 are positive correlations, and they can be negative from 0 to -1. So this graph here shows a positive correlation because, and it's positive because an increase in one variable is related to an increase in another variable. So of course the point of a correlation is that if you know one variable, you can predict the other variable. So this joke, according to the chart, you should be 47 feet tall, is based on the man's weight. And so given his weight, what you would expect, where you would expect him to fall on the height. So his weight is very high, so you'd expect his height to be high. So that's just a little correlation humor. So this chart shows a negative correlation. And so you can see that it's negative because a lower value of, on the x-axis, the birth weight variable, predicts a higher value on the y-axis, okay, so diastolic blood pressure. So when a lower value on one variable predicts a higher value on the other, that's a negative correlation. Okay, so as I said before, a correlation is a value that's calculated. You don't need to know the formula for calculating a correlation coefficient, but the coefficient is calculated from the data from two variables, and it ranges from +1 to -1. And this correlation coefficient is called R, okay, and so a perfect positive correlation is when each value of x predicts precisely a corresponding value of y. So over here you can see that a perfect positive correlation would look like that. It shows that there's a perfect linear relationship between x and y. So for every unit increase in x, there's a corresponding increase in y across the whole length of the scale. Okay, so this change up here in y is the same as this change, etc., throughout. And a perfect negative correlation is just the same thing but in the opposite direction. Okay, so down here shows the perfect negative correlation. So for every increase in x, there's this corresponding value increase in y, or actually, sorry, decrease in y. And then a zero, an R of 0, means that there's no relationship between x and y. So that would look something like this, or more likely to be distributed, around the line. But the point being that for every change in x, there is no change in y, no predictable change in y. Okay, so the lines for these would look like, for this one, it would be a straight line. For this one, the best fit line of the points would be like that, and the other like that. So for the two perfect correlations, positive and negative, the line is about 45-degree angle. So when you're talking about different correlation coefficients, as I said, they tell you the strength of the association between two variables. And as I said, the positive and negative one are perfect correlations. So that's the most strong association you can get between two variables. But then there are other levels of correlation. So this shows the strength of a correlation, and it depends on what you're measuring, but this is sort of just a rough guide. So you can see that, let's start from 0. This is no correlation at all. From 0.1 to 0.3, that's a weak correlation, either positively or negatively. And then from 0.3 to 0.5, that's medium, 0.3 to 0.5, negative and positive. And then above 0.5 is a strong correlation. Okay, so that just gives you some guidelines in terms of interpreting the correlation coefficients. So this slide shows the what different levels of correlation look like. So for this scatter plot up here, you can see the R is 0, so the correlation coefficient is 0, meaning there's no relationship between the two variables. Here's a -3, so that's a pretty low correlation, or as we said, like fairly weak correlation. And so that's because you can see they don't really, the values, the dots on the scatter plot don't really converge closely on a line. But you can see that it's negative relationship because the lower value on the x predicts a higher value on the y. So that's negative, but it's pretty weak. This one over here is a positive correlation. Now it's a little bit stronger than this one because it conforms more closely to a line. Okay, and then this one's even stronger than the 0.5. This is 0.7, although it's negative. You can see that the dots are getting more clustered together. Then as you go to 0.9, again positive, the dots are even more tightly clustered along this line. Okay, and then all of a sudden now here you're at almost a perfect negative correlation because, well, there is some variation along the line. They're not all exactly on a line, but it's they're very close to a line. So what this shows is that the closer that the scatter plot looks to a line, the higher the correlation coefficient is going to be. And that's because the correlation coefficient, again, reflects the strength of the linear relationship between the variables. So if there's a very strong linear relationship, like in this case, knowing the value of x is going to tell you with a great degree of precision what the value of y is. If you're over here with a weak correlation, knowing the value of x is not, there's still a whole bunch of variation among the dots that is not explained by this linear relationship between x and y. So that just gives you a sense of what a correlation coefficient is and how to recognize the degree of correlation or degree of association by looking at the scatter plots.